Hi, welcome to our latest video on ratios. In past videos, we've discussed what a ratio is, which is really a comparison between quantities. We've learned how to make a ratio by putting a colon in between two or more numbers. We've learned that order matters in a ratio, and it follows the same order of the words that we would use when we make this comparison. We use that same order when we use numbers to make that comparison. Finally, we learned how to simplify ratios by making each section into equal groups. In this video, we're going to learn about equivalent ratios. Now, every single ratio has an infinite number of equivalent ratios. We can make a ton of them. But there's one that's pretty special, and that's the simplest form. We're going to learn how to use common factors to divide and multiply to find a variety of equivalent ratios, and we're going to find missing numbers in a set of ratios by following a pattern. Let's get started. First, let's look at this ratio. I want you to see that it's represented in bars, and each of the kids, Jamie and Kelly, have some money. Jamie has 8 and Kelly has 12. So the ratio of Jamie's money to Kelly's money is 8 to 12. Notice how Jamie's name came first and Jamie's amount of money came first. The order matters in a ratio. Both 8 and 12 can be grouped into equal groups of 2. Since they can be grouped into equal groups of the same number, we can simplify this ratio. So now if we look at 1 unit of money being 2 of the coins, Jamie has 4 units and Kelly has 6 units. The ratio of Jamie's money to Kelly's money is 4 to 6. But can we go further? 4 and 6 can also be grouped into groups of 2. Now we look at 1 unit having 4 coins of money, so Jamie has 2 units and Kelly has 3 units. The ratio of Jamie's money to Kelly's money is 2 to 3. 8 to 12, 4 to 6, and 2 to 3 are all equivalent ratios. They have the same meaning or the same value. That's what equivalent means. You probably see the word equal hiding in the big word equivalent. We know that we can use small words that we find to help us understand the meaning of big words. So equivalent means having equal value. Now let's look on writing a ratio in its simplest form. Now remember, all 3 of these ratios are equivalent ratios. They have the same value. But the simplest form is one special type of equivalent ratio where you can't divide any further. You can't make the 2 numbers on either side any smaller and keep it equivalent. That makes it the simplest form. So to simplify a ratio, we're going to divide the terms by their common factor. In this case, they looked at 8 and 12 and realized they were both even numbers. They were both multiples of 2. So we divided by 2. 8 divided by 2 is 4, 12 divided by 2 is 6. And then we divided by 2 again. 4 divided by 2 is 2, 6 divided by 2 is 3. Now, another method we could have used would be dividing by the greatest common factor. 8 and 12 both share 4 as a common factor. If we divide by 4 from the outset, we get to the simplest form even faster. 8 divided by 4 is 2, and 12 divided by 4 is 3. So 8 to 12 is the same as 2 to 3. Now, it's very important that we always divide by the same number on each side. If we don't do the same thing to each side, then we won't find equivalent ratios. Now, let's practice some more. 5 to 3 is the same as 10 to what? Now we've got a mystery on our hands. In this case, we need to look at what happened to one side of the ratio and do the same thing to the other side. Well, how did I get from 5 to 10? I multiplied by 2. That means on the other side, I also need to multiply by 2. As we can see in our thought bubble, we've done those multiplication problems. 5 times 2 is 10, and 3 times 2 is 6. So our missing value there is 6. Now, I can check my work as well. I can go backwards. How could I get from 10 to 5? Well, I can divide by 2. Remember that multiplication and division are inverse or opposite equations, okay? So when I want to go forwards, I'll multiply, and when I want to go backwards, I'll divide. And I can use that relationship to get the same thing. In this final product, I'm showing that 10 divided by 2 is 5, and I'm thinking, what divided by 2 gives me 3? In the same way, we know that 6 is the number that fills this mystery box. We can follow patterns to find the missing number in a set of ratios. Now we have two more equivalent ratios. 18 to 15 is the same as mystery to 5. So this time, let's try the other way first. Let's try dividing first. Dividing first is going to make a lot of sense when your first ratio has larger quantities than your second ratio. Because when we divide, we make the number smaller. So 15 divided by 3 gives me 5. 18 divided by 3 gives me what? 6. You're correct. In the second method, let's check and make sure that works. Is 6 times 3 the same as 18? Why, yes, it is. So we found the correct number to go in the mystery box. Whenever we have equivalent fractions, we need to look for the multiplication pattern or the division pattern to fill in the box. We can use the opposite pattern to check our work. Let's do these together. 4 to 5 is the same as 8 to what? Look at our thought bubble. We've realized the connection between the first terms in each of these ratios. 4 to 8, how did I get there? I multiplied by 2. So you need to multiply 5 by 2 to find out the missing second term in the second ratio. Let's look at the next ratio. 21 to 14 equals something to 2. Now we know the second terms. So let's look at the relationship between 14 and 2. 14 divided by 7 equals 2. So I need to divide 21 by 7 to find the first term of the second ratio. Notice how I looked out for which terms we knew. In problem A, we knew the first terms of each ratio, but one of the second terms was a mystery. In problem B, it was just the opposite. We knew the second terms, but one of the first terms was the ratio. We always have to remember that we're doing the same thing to both sides. Now, here's something tricky. Remember that I mentioned that there's a bajillion equivalent ratios for any given ratio. There's so many. So in this case, you have 4 potential choices, and 3 of them are correct. Look at 3 ratios that are equivalent to 7 to 6. Really think through your times tables here. You should be thinking 7, 14, 21, right? And 6, 12, 18, When you see a multiple of 7 or a multiple of 6, that should spark the intention to check to see if those ratios are equivalent. Now remember, the order matters. So let's look at option A. In option A, we have 12 to 14. Well, 12 is a multiple of 6 and 14 is a multiple of 7. This bears some investigation. So I noticed that in order to get from 7 or 6 to 12 or 14, I'm multiplying by 2. But I need to check on the order. From the first term to the second term. How do I get from 7 to 12? 12 is not a multiple of 7. How do I get from 6 to 14? 14 is not a multiple of 6. So A is not a correct answer. I want you to look at the other answers and see how they follow the correct order. See how they use the same times table multiplier to move from 7 to 6 to these other ratios. Remember, there are infinite equivalent ratios for any given ratio. Now we're going to look again at simplifying equivalent ratios. We need to write these ratios in their simplest form. That means we need to divide by a common factor until we can't divide anymore. I'm just going to help you find the common factors of each ratio, and then I want you to do the division. 3 to 6. 3 and 6. What factors do they share? Well, 3 is a prime number, so its only factors are 1 and 3. Is 3 also a factor of 6? Why, yes. Then I need to divide both sides by 3. 12 and 36. Let's look at the different factors of 12 and 36. They have many. When I see big numbers, I always want to start and think, are either of these numbers factors of each other? Does 12 go into 36? Think about our 12's times table. 12, 24, 36. Why, it does. So let's divide by 12 because that's going to be the greatest common factor, right? No number has a factor bigger than itself. We can do the same process with 5 and 15 because I notice 15 is on the 5 times table, so I know how I can divide there. 16 to 56, Now this one might be a little bit trickier for you. If you're not familiar with the times tables up to that level, we can always start by dividing by a simpler factor. 16 and 56 are both even numbers. So first, divide by 2. Okay? Then you can see what you get and see if you can divide again, right? Very good. Try these on your own paper. Next, I'd like you to fill in the blanks. Now notice, we have some terms visible and some terms missing. We always have to look for where our mystery lies. So in the first problem, E, 1 to 6 is the same as mystery to 18. We know the second terms, but we don't know the first terms. How did we get from 6 to 18? We multiplied by 3. So I need to multiply 1 by 3 to find the missing term, that first term in the second ratio. In problem F, we know the second terms and we don't know all of the first terms in the same way. So I have to ask myself, how did I get from 13 to 26? And I need to do the same thing to get from 5 to 10, to the blank. Sorry, I gave away that mystery. Now, those diagonal lines don't mean anything, so let's keep moving to problem G. We know the first terms, but we don't know the second terms. How do I get from 5 to 30? Okay, how can I do the same thing to get from a number to 6? This might be a problem where it helps to work backwards, since one of our missing quantities is in the first ratio. So you can also think of this as, how do I get from 30 to 5? Since I'm going from a larger number to a smaller number, I want to use division. And then I can do from 6 to the mystery number with division as well. In H, I also see that a term from the first ratio is missing. So I'm going to look for a way to work backwards. I have blank is to 6 as 9 is to 27. So I'm going to go from 27 to 9 with division. I'm going backwards here because I have a missing term in the first ratio. Look for division and multiplication patterns to find those missing terms in equivalent ratios. That's all we've learned today. So use what you know to find equivalent ratios, put them in their simplest form, use common factors to divide and multiply, and use patterns to find missing numbers in ratios. Thanks for watching.